Good morning, everybody. Welcome to our Friday morning West Coast time, United States Space Show program. I'm your host, David Livingston. Thank you very much for tuning in. Most interesting discussion is coming up
Good.
in just a minute. So let me first make a couple of very quick announcements. We'll be with us for this program for 60 minutes, so just want to put that out there. If you're not getting our newsletters or reading our post on Substack about our upcoming programs and you want that information, uh, email me at drspace, DRSPACE, at thespaceshow.com, and I'll be happy to put you on our email list. The information goes out early Monday morning. Again, that is West Coast time. So everything we do is audio archived at thespaceshow.com. It is audio and video archived at Substack, and that is Doctor space dot substack.com. And we are starting to put videos up on YouTube, and our channel on YouTube is The Real Space Show. And the reason it's The Real Space Show is, believe it or not, there are other space shows on YouTube, not necessarily in America. So our trademark doesn't work outside the United States. And also, you can't fight a trademark issue with YouTube because they have more money than everybody else. So it's a dead issue. So we are The Real Space Show on YouTube. And coming up is an open lines discussion. And then we have some interesting program shortly after that with Bryce Meyer on growing food in space, a European guest, Manuel Cuba, about funding space startups in space. And then with much demand, Isaac Arthur is back with us on Sunday, December 14th. So if you have any questions, email us. Don't forget, we're in our fundraising period. We are a nonprofit. And if you like us, please support us. And the support information is on our website. But real quickly, go to the right side of our homepage, thespaceshow.com. There is a PayPal button, which also gives information on Zelle if you use the United States Bank, and also mailing checks to our offices in Las Vegas, Nevada. And if you're a Substack user, you probably know how to subscribe and donate through Substack. It's a little bit of a different process. For today, we have a very well-known, respected, award-winning uh, UK science author, Brian Clegg. He's very popular. He has lots and lots of books, but Dice World and A Brief History of Infinity were longlisted for the Royal Society Prize for Science books. He also has written for Nature, the BBC, the Times, and many other books. If you go to his US Amazon page, I didn't go to the UK Amazon page, you'll see an entire list of great books by Brian. But the one we're talking about came out this October, The Multiverse, When One Universe Isn't Enough. And we're very happy to have Brian Clegg join us for this discussion. With us is John Hunt, Marshall Martin, Dr. Sherry Bell, and John Jossi. Brian, welcome to the Space Show, and it's very glad to meet you and to have a chance to talk to you. I've been reading the Multiverse book, very interesting. For people who are listening to and watching this show who may not know what a multiverse is, let's start out with a definition. And is your definition mainstream science's definition, or do you take literary license and let fantasy go a little wild? Because I know that's possible with the multiverse. And again, welcome to the Space Show.
Thank you. It's great to be here. I'd say a multiverse is essentially something more than just the universe as we normally think of it, which is puzzling because originally the universe simply meant everything. There was nothing else in physical space and time. But partly coming out of fiction, and I think you do have to be aware of that. You can't watch a Marvel movie these days without multiverses coming into it. This extension of the universe idea has come about. And there are various different ways you can look at it from a scientific viewpoint. There might be multiple universes because there are more than four dimensions. There might be multiple universes because there's been more than one Big Bang, if you like, happening in different parts of a wider concept. Or there might be multiverses physically coming out of the fact that quantum theory, some people would argue, suggests that there's just not one universe in terms of what happens, but there are actually many, many universes. But I don't think we can ignore that fictional side, because it is significant to a lot of people's understanding. And frankly, I suspect a lot of the scientists who now talk about multiverses were probably inspired by fiction when they were young.
Is there or will there ever be a way to scientifically confirm multiple universes?
It's pretty difficult because if you think, for instance, of the idea of having multiple expanding universes that have come from a set of big bangs, if you like, that inflation's been happening in different parts of a wider space, the whole concept requires that there's no communication between these universes effectively. Some people suggest very indirect ways it may be possible to detect it. But as yet, I think it's fair to say mostly that it is almost a philosophical idea that's been using physical and cosmological arguments, but it's philosophical in the sense we can't really prove or disprove the existence.
Um, so your book title is very intriguing to me. When one universe isn't enough, why would we need more than one universe? Or I don't even know how to ask the question, but why would the world, maybe the world, everything that we could possibly imagine, why wouldn't that be enough? Why do we need another of us? It's almost like another Earth.
Yeah, I think one of the reasons I'd come to that when one isn't enough is that one of the reasons that people have argued for the existence of a multiverse is to deal with something called the fine-tuning problem. So we know that there are various constants of nature that if they're only very slightly different, we couldn't exist, physical matter couldn't exist. Sometimes it's a very small change involved. So, for instance, if neutrons were just maybe 1% lighter than they are, atoms couldn't form. And there are many, many of these fine-tuned details. It's kind of a Goldilocks universe we live in. And people are looking, if you like, for a reason behind that. And some people have argued that it's possible that an explanation for this, so a need for a multiverse almost, is that if you have lots of different universes which have different physical constants, then inevitably some of them will have the right constants for life to exist, for us to exist. And if that's the case, then we have to be in one of those universes because, of course, if life wasn't possible, we wouldn't be here. Um, it's actually, I suspect, a rather dodgy bit of statistics. I think statistics, frankly, is being stretched beyond reasonable doubt to come up with that argument. But I know quite a few cosmologists do make use of that to say there really ought to be a multiverse because of the fine-tuning problem.
Would we be in each universe? And what is the difference between different universes and dimensions?
In that particular approach, if we're saying, the multiverse should be there because of the fine tuning problem. No, we're not talking about basically multiple different versions necessarily of the same universe. In fact, the vast majority will probably not have any matter in at all because they would not be having the right physical constants for matter to form for life to exist and so forth. It would be only a relative minority, because the argument from fine-tuning essentially says this is a very unlikely universe that we live in. And the fact that it's saying it's very unlikely, the vast majority of other universes in that picture of a multiverse would not be like ours. And that's very different from the kind of multiverse that comes out of the many worlds interpretation of quantum physics. I mentioned this sort of very different approach that comes from quantum physics. There we are talking about, were it true, if you like, many, many universes which only differ in some cases by one quantum particle having done something different.
Uh, Pretty fascinating. Is it widely accepted, the multiverse theory, or is it uh, sort of so-so accepted?
I think it's one of those things, like a lot of scientific theories that are really a little bit towards the edge. So most cosmology, frankly, for instance, it's one of these places that there will be some scientists that do champion a particular approach. So some do suggest, for instance, that there are these many universes that solve the fine-tuning problem. Um, Equally, some physicists in their interpretation of quantum physics, like the many worlds interpretation, which I mean, it takes back to the 50s, but it still has some following. I think it's fair to say, and I think we have a real physicist here, I'm a writer in the end, who could probably say more, but I think it's fair to say that there are probably more physicists who are happier with a more basic interpretation of quantum physics, whether it's Copenhagen or something a little bit different, but probably wouldn't say that the many worlds interpretation is their particular view. But there certainly are some who do think it's an interesting possibility.
Could we somehow communicate with another universe or glaze into it or pick up signals from it or something?
Well, I think if we're talking about a conventional cosmological multiverse, the simple answer is probably no. That we can mathematically suggest the existence of these other universes. Although, as I say, I think the statistical argument for fine-tuning as a reason is actually quite doubtful because it verges into something called the inverse gambler's fallacy as far as statistics is concerned. Uh, Many worlds, there has been an argument from David Deutsch, one of the interesting quantum physicists, shall we say, that if you had effectively a self-aware quantum computer, it might be able to detect the fact that there are these many worlds, these alternatives, that they somehow are interacting with each other. But again, I suspect the majority of physicists would probably say no. You know, the trouble with the different interpretations of quantum physics is they all pretty much predict exactly the same things. It's just the many worlds interpretation has been suggested as it might be useful because it does away with the idea that all the possibilities, if you like, collapse to a particular possibility when, say, a quantum particle interacts with its environment. And many worlds does away with that. But I think most people would say it does away with it by introducing so much extra baggage that it probably is not a sensible interpretation in the end.
So I know,
One thing I'd mention, if I could, about that is it does seem to solve this spooky action at distance problem where two coupled things can, when quantum states can resolve themselves across vast distances in principle in violation of the speed of light situation, since they would split into the relative universes where one's in one state and one's in the other.
And for that matter, there are other interpretations, like the Bohm interpretation that also do away with that. But I think realistically, if you take just an Occam's razor viewpoint, the idea that there are uncountably many universes effectively created every time a quantum particle does anything seems kind of overkill to do with the fact that we struggle to understand exactly what's happening, when you have a collapse of quantum states to a specific thing happening. I know there are some people who support it. Maybe you do, But I think the majority of physicists would now say that they don't.
Hey,
That's
John.
probably true.
John, I have a question to follow up on your entangled particles.
Mhm.
So that phenomenon happens in our universe. So why do you have to invoke another universe to explain that? I don't understand what you're getting at there.
Well, that's in the many worlds version where you have this universe itself is kind of like a big branching phenomenon with every quantum event presumably creates a different branch. And therefore it's like a massive net kind of.
Okay, I got you. All right.
Okay.
I know, Brian, that your book addresses inflation. So,
Mhm.
inflation's, I guess I'll say pretty well accepted, but of course nothing is proven in our universe. Could another universe not be based upon inflation?
Absolutely. This is kind of this eternal inflation idea that it's happening at, if you like, different times in different parts of the early universe, and you have a set of bubble universes that are all growing. One of them's ours, but they don't intersect. In that model, they are, if you think of a set of soap bubbles floating on top of some water, and those bubbles are expanding, they don't expand into each other. They expand into, you know, in the case of that, the water space. But of course, we're thinking about expansion of space itself. So there's no limit to the ability to expand space itself. We're not talking about expanding into space. We're talking about each of these universes, if they exist, being expanding space in their own right.
Marshall?
Uh, my question comes from grand unification theory and application of string theory, and they talk about having as many as 11 uh, more dimensions to work through. And because of flaws between the 11 dimensions, therefore we get gravity. And you kind of sit back and go, okay, sounds like a bunch of theorists off in a corner having fun. But
Hmm.
my question to you would be, is there anybody that's talked about these added dimensions being part of dimensions in other universes and there being some commonality through the mysterious added dimensions, which might in turn reflect on gravity?
Yeah, yes. So it's what used to be called the ekpyrotic theory. They've given it a new name, which I can't remember, frankly. But it came out of M theory, so the extension of string theory with the extra dimension thrown in that unites the five versions of string theory. And the idea is that you have these three spatial dimension brains floating in this larger multidimensional space, that they interact with each other occasionally, and that gravity, as you say, is leaking from the brains out into this
Mhm.
wider space, which occasionally pulls them together. And the suggestion is that in that theory, that the Big Bang was effectively caused by two brains hitting each other, and that results effectively in a smoothing out of the nature of what's happening in that particular brain. I mean, as with all these things, it's interesting. I believe, again, I have to stress, I'm a writer, not a physicist. I believe that other physicists say there's quite a lot that hasn't really been sorted out in that theory. That it's nice as a picture, but when you get down to the fine detail of the physics, there's quite a lot of gaps. Of course, string theory itself is not really accepted as a definitive theory anyway. So we're kind of building to some extent speculation on speculation when we come into that. But I just think it's interesting to think about. And one of the conclusions I came to in looking at all these different aspects of the multiverse is not so much that this is something that's explaining anything per se, but rather it's something that makes us think about things a little bit more. It's interesting to think about. As I say, it verges into philosophy as much as it does science about what would be the implications of having multiple universes, even if they can't communicate with each other. Um, but how much you can actually say this is science that everybody can get behind in the same way you might say about quantum theory or general relativity or whatever. I frankly think with a lot of this, we have to say, okay, it's interesting speculation, but the evidence is limited.
Brian, does a multiverse answer any questions that physicists are trying to answer in our universe? And then if we take a look at history and we go back to the Greeks, we go back to the Persians, they were interested in celestial activity and
Mm.
a few others. Did they have any concept or leave us anything that makes us think that they imagined or thought about their equivalent of a multiverse?
I'll be honest. I think the trouble is their picture of the universe was so different from ours that, in a sense, yes, they might, but it wouldn't be talking about the same thing. So, the ancient Greek picture of the universe was pretty much the solar system. There's very little beyond that in the imagination. At that point, they obviously didn't have the scientific basis to find anything about the universe. It was very much a philosophical speculation. Um, but if you go back, for instance, to uh, sort of Greek period when they were thinking about how big the universe is, most of their pictures of the universe were typically, between maybe about the orbit of Saturn or something like that in scale.
Mhm.
The sort of Aristarchus calculation on that, I think, was about the orbit of Saturn.
When the telescope was invented, did that start to change the idea that there was a universe larger than our solar system?
Well, I mean, of course, there was a lot of debate once you went beyond the solar system, how much more there was. There was the big debate in the 20th century, the start of the 20th century, between is it the Milky Way or something more? But obviously, yes, the telescope had an impact in terms of bringing in a lot more information. The starting point was, where are the stars? In the ancient Greek picture, they were basically a sphere on the outside of the spheres of the planets, and so they would be on the scale of the solar system, but as I say, perhaps at the orbit of Saturn. As it became clear that there were a lot more stars and that they started to be able to do a little bit of parallax work, so they could get distances to very close stars, it became clear it was on a scale that was very different. And then you had obviously people like Herschel starting to see what he called nebulae, but we now know to be other galaxies. And so gradually the scale has become bigger as we find out more about what was out there.
When does modern day multi-universe thinking start to show up?
Um, that's a good question. As I say, that the many worlds hypothesis, so the quantum version is definitely from the 50s. Um, Inflation's late in that, obviously. So if you're talking about, and particularly if you're going on to the sort of bouncing brains coming out of M theory, we're moving towards the end of the 20th century. Um, but the actual sort of idea of there being many, or at least more dimensions than the four that we have. So potentially you might have a different kind of multiverse that was just in another set of dimensions. I think primarily came out of fiction in the 1920s or thereabouts originally. I think the earliest example was either 20s or the 30s. Although interestingly, I think the very first fictional extra dimension, as it were, universe was adding a dimension of time, one dimension of time, rather than adding three extra dimensions of space.
Does it answer any questions that physicists are trying to answer and can't answer?
As I say, again, I'm very happy to hear what other people think, but for me, the only, if you like, practical application that has been made has this idea of trying to explain why our universe is so fine-tuned. But as I say, I think unfortunately, the way they're using statistics there does not hold up. They are, if I can just describe to you what's happening with that, And what they say, as I say, is that because our universe is something very unlikely, and they don't obviously want to think about the possibility it was created in any way, then there must be lots of other universes for ours to exist. And I think a really good example of why this is faulty thinking is, as I said, this inverse gambler's fallacy says basically, okay, you walk into a casino and the first person you see is winning time after time. And your cosmologist friend who's with you says, oh, because that person is winning a lot, the casino must be full. Um, because it's very unlikely a person will keep winning over and over again. So there must be lots of people in this universe, as it were, that is the casino. But actually, you've only observed one person, and it tells you nothing about the other players whatsoever. And similarly, strictly, we have obviously only observed one universe, and to use statistics as a way of trying to prove that there are other probable universes, I think is pretty dodgy.
So if we're finely tuned, how can things randomly happen, or if it's not created, how to be finely tuned, it would seem to me there'd have to be some kind of master plan, like an engine or something that, where everything has its place, but it was designed
Mhm.
to function in this way. So I know that really does go philosophical, but it would seem to me you can't have finely tuned and randomly created next to each other. I don't know. Is there a fault in my thinking?
There's obviously no reason why you couldn't have both. It's just fairly unlikely, shall we say? But in the end, it has to be something. Uh, but there's certainly people. I mean, one of my big heroes as a physicist when I was young was a guy called Fred Hoyle. He
Mhm.
was an astrophysicist, a big thinker, shall we say, somebody who's prepared to challenge ideas. He was a very strong atheist. Um, Yet he actually said that because of the fine tuning, there had to be some kind of organization from outside, as it were, or part of the universe organizing itself in some way, that there had to be some kind of structuring. He thought it couldn't happen randomly. Now, whether or not you go for that line, I don't know. I've also seen fairly recently a philosopher whose name's escaping at the moment, suggesting it actually is evidence for pantheism, the idea effectively that the universe itself has a form of uh, consciousness almost that can direct itself. Again, we're into heavy duty philosophy here rather than physics.
Well, you do title your chapter Fine Tuning Conundrum. So apparently there is a conundrum with it. But I don't know, maybe the others have a different idea of fine tuning, but um, it doesn't seem to me like random goes with fine tuning, but I'm not sure. John, your thoughts on that?
Well, I think this is really a so-called anthropic principle that more for conscious beings like us to exist, you have to have a universe that has the physical properties where we could evolve in it, right? And that's what they're saying and that's why it's fine. If those certain properties weren't there, we wouldn't be here as we are physically, right? I mean, that's essentially it. And therefore, the idea is if you had a whole large number of other universes that had different properties, one of them would hit the mark or something. Or I think that's what they're trying to get basically.
Mhm. Uh, Let me ask this question. We have Planck's constant, making a whole series of related things about the very small, but in turn, you can take Planck's constant and several other constants, and you find out that they're interrelated. Has anybody come up with a general theory that all constants are basically extrapolations of one basic constant, like Planck's constant?
I'm not aware of that, I have to say. I think people have tried, but I think it's pretty difficult to come up with a reason for that. Can I just very briefly pick up on what John mentioned? Because the thing about the anthropic principle is there are two levels of it. So there's the weak anthropic principle, which everybody can get behind, not a problem at all, which is exactly this thing that the universe has to be the way it is, or we wouldn't be here to see the universe as it is. But that doesn't explain in any way how it became. Then there's a
Mhm.
strong anthropic principle that says in order to that happen, you've got to have all these other universes out there so that there's a fair chance it's going to happen. But as I say, the two problems with that. There's one I mentioned, so you're misusing statistics, but also we know, as far as we're aware, these universes don't communicate. So how do they even know, if you like, to all have different constants? Why do we assume that? We could have a multiverse where every single universe has exactly the same constants, or everything else hasn't, all the other universes have nothing in it. We can't really draw any evidence from this one observation of one universe, the one we're in, about any other universes.
Yeah.
So,
That's a good point.
um, I have a practical question for you.
Mhm.
So, um, I can see that writing this book and thinking about and planning it, I can see you working on your computer at 2 a.m. in the morning, for example. I don't know if you did that or not. And you're so deep into the weeds of the philosophy and trying to work it out, and you can't work it out. So how do you get out of the weeds to write your book? Because really and truly, if you don't have an incredibly disciplined mind that can separate all of these theories and these ideas and the ifs and whens and all that, you'll never get past your introduction. So, what are your tricks to stay out of the weeds?
I think because my job as a science writer is to try to explain what is the thinking of various scientists, what are the theories that are presently supported. Um, my starting point really is to get an overview, and then what I'm trying to do is present the different views, the different ideas that are out there. And I think you can structure those reasonably without hopefully getting in too much of a tangle. I think part of the problem we have with something like the multiverse is the tendency to overhype. Um, One thing I did towards the end of the book is basically I went onto a news site and searched for multiverse and just looked for the headlines. And there are so many of these incredibly overhyped headlines where the fact is they're not telling us anything new. I'm afraid, dare I say it, one or two science magazines love having headlines that are really over the top. So, I mean, just if I can just show you, just talk you through a couple that I came across. One, for instance, was our reality seems compatible with a quantum multiverse. So this is the many worlds approach. Of course, it's compatible with the quantum multiverse. It's also compatible with there being an invisible dragon in my garage back home. Um, yeah, and I do. I have an an invisible dragon in my garage. Unfortunately, it is invisible. It's weightless, and also it's made of dark matter, so you can't actually touch it. But it's there. I know it's there, and it's a bit like that. You know, the quantum multiverse, or even, frankly, a lot of the multiverses. It's interesting to speculate about, but the evidence isn't there. And the trouble is, we get all these headlines. Another one I read was Google claims it has discovered staggering proof that we live in a multiverse. But actually, it was just an analogy. All Google was saying was in a quantum computer, there are multiple paths through the quantum computer. And that's a bit like this idea of the branching multiverse with all these different paths through it. But it was literally just an analogy, not a staggering proof. And I think part of the problem we have is so many of these headlines claim more than is actually what the scientists are themselves saying. Uh, Possibly also because the PR departments of universities, frankly, like some good stories to get the money in. So they sometimes perhaps slightly oversell what it is that the theoreticians are saying.
You also have a chapter about colliding universes. Now, we know our galaxies collide, like Milky Way and Andromeda are going to meet someday down in the future. None of us will be here to see it. But
Mhm.
why would one think the galaxies would collide? That would would seem to indicate that there's a relationship between them and, again, for lack of better wording, their paths or their movement or something, if they're going to collide and intersect.
Yeah, that particular chapter really is about this one based on M theory. So what we're talking about these each universe being a multidimensional brain floating in this wider space, and they're colliding because the theory is the reason that gravity is so weak. Gravity is an incredibly weak force compared with the other forces. Um, People don't always accept this, just non-scientists. But if you think about it, I think a great example is a fridge magnet. Tiny little fridge magnet. You put it on your fridge, it stays there. That magnet's holding it. The Earth's trying to pull it down. The Earth loses. The Earth is losing against this tiny magnet. Gravity is very weak. Why is gravity so weak? Well, it'd be quite nice if we had all these different brains floating around and gravity was leaking out of them. That was causing them to come together and occasionally collide. And that was what I was really talking about in terms of colliding multiverses. If you look at the one that's based on inflation, it's not really a collision because it's more a case of, as I say, like expanding bubbles, expanding into because the space is expanding. And with many worlds, there is no collision. It is literally kind of branching out there into into whatever that multiverse really is.
Um, so another thought I had when I was going through the book, many of our listeners and probably people that pay attention to space all over the world have a spiritual connection. And I'm using spiritual to replace religious because I don't want to deem it religion, but it could be
Mm.
religion, but it also could be California New Age spiritual. But there's or like astrology with the Zoroastrians or something. They have a connection to it or a spiritual thing to it.
Mhm.
Would that transcend uh, our only one universe? Would we see all universes as our universe? I mean, I'm trying to think if we combine it all together, and if you're talking to someone and they say the universe, are they including multiverses, or are they uh, just thinking about ours? They may not know about multi-universe. They may not have that kind of education, but
Mm.
I'm trying to expand to see how people might connect with the idea that there's more than one universe if they feel there's something spiritual about space.
Yeah, I mean, in a sense, that came out, I guess, at the end of the 19th century, when spiritualism was on the rise, and they started talking about another plane, this was, I'd suggest, in some ways more related actually to the sort of fictional concept of parallel dimensions and that kind of thing. But their idea was that when people died, they passed to effectively another dimension, another plane, and you had that spiritual connection potentially between these planes. I don't think this is in any sense science. In fact, I'm absolutely sure this is not in any sense science, but it is something that certainly a lot of people feel they can relate to. And as I say, you then get to the kind of fictional concept of the sort of the parallel dimensions, the demon dimensions, and all that kind of stuff that you get coming up in various works of fantasy.
I'm surprised I haven't heard, and maybe John could say something about this, that the extraterrestrials that so many people believe in aren't coming through somehow from another universe instead of someplace in deep space. Uh, is there any, so therefore they have a way to communicate between universes. Have you come across that? Is that at all part of the philosophy or thinking about multiverses? Life could communicate between um, different universes somehow.
More
Advanced.
like science fiction, isn't it? I mean, in science fiction, you have the idea of parallel worlds and going across them, and that does occur in some science fiction, but physics it would be an open issue, I'd say, at least, right?
Well, but then you're assuming that physics is the same for all universes, and, and
Mm,
maybe another universe has a different set of physics.
yeah. Well, I mean, you have a problem with either idea. I mean, how do you get across these universes? I mean, the bubble ones would be so far apart physically, I guess, in some sense. I guess it would be pretty hard for it to happen. You know, the multiverse concept isn't the quantum theory doesn't allow it as we know it now. It'd have to be modified in some way. And of course, time travel is the other thing you have in that some people like to. I'm not for that. But if you did have time travel, you presume to have a multiverse situation. Is when you go in the past, you're changing the situation where you weren't there before. Gets rid of the idea that if you somehow did in your own parents or something, or cause them not to get married or something, then you wouldn't exist. So you'd be creating a new reality if you went back in the past, right? It would branch off. I mean, it'd be the one without you there and the one now with you there, right? But those are
I
kind
think
of some science fictional type concepts, I guess, or philosophical ones.
My question to you, John, is
Hmm.
do you think that the UFO space aliens, even if they can travel faster than the speed of light, can they communicate faster than the speed of light so they can report back to their home base in a reasonable amount of time?
That's an open question. I don't know if we know that, but of course, they might have to rely on courier vessels, I guess, like we did back before we had electronic communication and telegraph and everything, right? I mean, we, we just don't know that. There's so much we don't know about that subject. That's kind of getting off of what we're talking here, though. But yeah,
Yeah.
yeah,
Well,
so bringing us back to reality here.
well, it's real, but it's different. But it's
So
not the topic here.
I have a question, Brian. I dropped off. I don't know if you guys touched on this while I was offline, but um, the the possibility of these different universes impinging on each other. My understanding is, or the theory behind one theory behind the multiverse is that each universe is started from a quantum fluctuation, and
Mhm.
and then inflation happens, at least in our universe. That's the theory, and so you've got these different bubbles that randomly form, and if everything is random, then they're not going to be evenly distributed. Some will be closer to each other than others. And if one particular bubble happens to be close to ours and impinges on it, what would that look like? And would we be able to detect it? I mean, would there be some sort of um, radiation or some way that we could detect if another universe is impinging on ours?
I think the problem with that picture is that those who argue for the idea of having many different expanding bubble universes will say they won't impinge on each other because that would imply they were expanding into space, but they're not. It's space that is expanding itself. So there's no into involved, if you see what I mean. That if you can imagine each bubble is expanding, but it's the space that's expanding. It's not expanding into somebody else's space. So they don't overlap. They never overlap. In fact, I don't think any of the actual scientific multiverses have a concept of a portal or anything like that where there's an intersection between universes per se. I know the bouncing brain ones, in principle, kind of interact with each other, but again, they don't sort of move into each other. They don't move into each other because it's the space itself that's expanding, not expanding into space, as I
So,
understand it.
so that raises the question of what is between the two spaces? If that's not space, what is it?
Well, there doesn't have to be in between, in a sense. It's a bit like the problem with, some people worry about, if you think about the Big Bang, the argument is that if you run the universe backwards in time, effectively, it gets smaller and smaller. And we know the visible universe is, a particular size, 90 billion light years across or thereabouts. We have no idea what's outside it, and it may be infinite. The universe may be infinite. And even despite that, the Big Bang approach still says the whole thing started as a point. And people struggle with how can you kind of mentally run backwards from something infinite to something that's a point in a finite amount of time. And the reason is because it is space that expanding. It's not expanding into space. So what it's more like is if you think 2 points in that space, the distance between them is getting smaller and smaller. And that's true all over. And if you do that, you can actually get from something infinite to a point in a finite amount of time. It's easier to think of actually if you think of a number line, a mathematical number line, an infinite number line. If you imagine it's split up into, say, 1 inch blocks, if you imagine each 1 inch block goes down to zero, then the number line has no length, even though it was infinite originally. So as long as it's the distance between things that contracts, because it's space that's contracting. If you imagine running it backwards, you can actually have an infinite universe that started at a point. And I think that's one of the things that really throws people because they're always thinking about space as something you expand into rather than the space itself expanding.
May I add a mathematician's point? As you said, as the unit of measure on your number line gets smaller and smaller and smaller and smaller, the total number line still stays infinite. And that's one of the problems when you talk about infinity theory to people. It's kind of like, oh, well, we'll squash it down to by a factor of a billion. It's still infinite out at the end. And if you expand it by a billion, it's still infinite out at the end. And infinite plus infinite is still infinite. So it's crazy math.
It is, although I could be wrong, but I think it's fair to say it's true if the distance is finite, but if the distance is zero between each point, I don't think you do end up with infinity. No. I think you go instantly from infinity to nothing, but I could be wrong.
Well, a mathematician again. When you divide by zero, you get uncertainty.
Yeah. Yeah. But all I'm saying really is I was trying to use that as a metaphor for the idea of the expanding universe, that it is the distance between things that's shrinking, not the actual size of something in space, because it isn't shrinking in space.
I want to bring up something here that might be familiar with. Sir Roger Penrose's couple of other novel cyclic cosmological theory. Have you looked at that, and what's your opinion of that, and what do you think the scientific community in general thinks about that?
I think, to be fair, that it's again in this sort of bracket of interesting but no evidence kind of thing. The ekpyrotic version, the brains one, also lets you have an infinite universe, usually in time, that is, that has basically effectively restarted again over and over again. I think in Penrose's version, it's more a case of being able to have one that has sort of crunches and expansions, but the standard version of that has a problem because basically over time you would find I think you have a problem with the fact that the degree to which you are my brain's gone blank, sorry, the degree to which you're normally you expect that you will find over time the degree of chaos, if you like, in the universe increases. But if they have this idea of it collapsing and then bouncing, there is a problem there, I think, in terms of continuity with if it's just a basic collapse and expansion. But I think Penrose's version is a way around that, but I could be wrong.
Yeah. I don't understand either. I've read his book, but
Yeah.
I can't quite grasp why the thing would start over again. He has it expanding forever to almost entry by death, and all of a sudden, voila, we're in a new universe. I'm like, huh?
Yeah.
It would
Yeah.
seem to me, Brian, that if you look at all the scientific disciplines, that there's a purpose for everything that happens, even if we don't understand the purpose. So if we now go to multiverse, there must be a purpose for it. Otherwise, it would not exist. I mean, it wouldn't exist just to be worthless out there like a hangnail. Uh, so if you were letting imaginations run wild and fantasy and philosophy, how would you philosophize or imagine the purpose for multiverse?
Um, I think the ancient Greeks would be happy with the idea of a purpose. I think modern science, on the whole, tends to avoid purposes.
Hmm.
Um, that it just assumes effectively a set of mechanical processes that lead from point to point without a purpose. Um, if you want to have one, I'm very happy for there to be a concept of being a purpose. I think we are then straying into either philosophy or religion, which is fine. And as I say, even Fred Hoyle, who was a devout atheist, if you could call an atheist devout, said he felt there had to be some sort of guiding force, that it absolutely wasn't a matter of organized religion in the way we understand it, but there had to be something that was shaping the universe. And then that obviously implies a purpose, because why would something be shaping the universe if there was no purpose involved? But again, we are very much in, the realms of philosophy or religion at that point.
So is the multiverse discussion more of a science discussion or a philosophy discussion?
I think I'd say it's a bit like there's a physicist called Sabine Hossenfelder, who has come up with the term
Hmm.
ascientific to suggest there are some things where science cannot contribute because there is no specific evidence that can be used to test whether or not a theory is true. It doesn't mean it's not true. It could be true. And it doesn't mean it's unscientific, but it's ascientific. It doesn't have that, ability to actually do anything beyond speculate. And it's interesting to speculate. It's fun to speculate. Physicists can use great mathematics to do their speculation, but it doesn't make it any more based on evidence, just because the math works.
Is it taught in graduate school and in physics and astrophysics classes, and how is it taught?
I don't honestly know. In my day, I mean, I did a undergraduate degree in the 70s, so it wasn't back then, but it may well be now. I don't know.
Are you writing a sequel to this book?
At the moment, I'm working on a biography of the electron, so something a little bit different, but trying to look at sort of how we've grown our understanding of the electron and its role in the world, from the very early days, from the very early experience of electricity and all that kind of stuff, through to modern quantum physics. So slightly different take on it, but most of the stuff I write is either physics or math based.
So I know you've written many books. Is there one topic in science or physics or astronomy that seems to catch the general audience, the readership more than others? And what would that topic be?
I think of the books I've written, the two that I get the most response from, one is one about quantum entanglement, so this spooky action at a distance type stuff, that had a lot of interest, and the other is about time machines, time travel, because there is technically nothing in the laws of physics, as it were, that prevent time travel, and forward time travel is very solidly established in terms of special relativity. Traveling backwards practically, I think, is very unlikely. But again, there are some interesting speculative theories. But I think that's probably the one that captures people's attention most. And come back to this idea that I think when you're writing about science for the general public, it's not a bad thing to be able to bring in things like science fiction to put things into context and then say, yeah, well, this is verging on something that's real. This, frankly, is just made up. But time travel seems to be the one that really gets people most, I think.
Um, yeah, it's really interesting, but there would be no rule that says another universe might have time travel, even though we don't know it. So that would not be incompatible with multiverse theory, would it?
Yeah, although as I say, we do know it. It's just limited. So, Voyager 1, for instance, has traveled about 1.1 seconds into the future from our relative viewpoint. Um, uh, into the future is pretty easy. You just have to move fast. It's a bit harder, to say the least, to get into the past. But yeah, of course, in principle, in a different universe with different rules, the problem, I think, then is still getting over the problems that arise, like this idea of the go back in time and kill a grandparent. My favorite one actually is a way of helping writers is basically you send your books into the past, give them to yourself, and you don't have to write them. You just hand them into the publisher, having bought them in the future. I think that's a great sort of effort saving possibility.
Uh, for those of us in the meeting room with us, we've got about 5 minutes left. If you have a comment or question, now is the time to bring it up. Is
Uh,
there
I'll,
anything?
I'll,
Go ahead, Marshall.
I'll ask, I'll ask one quickly. Why did you choose the electron over the proton or neutron as your next book?
Well, an electron is, of course, a fundamental particle, which the proton and the neutron aren't. Uh, but also, I think because it has this, if you like, wider scope, so people have been aware of electrical phenomena long before they were aware of the existence of the nucleus. People knew about lightning before we knew anything about science at all. They didn't know what they were knowing about. They knew about rubbing amber. The Greek ancient Greek word for amber is actually electron, but with a K. They knew about rubbing amber and getting that little crackle of electricity. Again, long before we had the scientific basis. So I think it makes more of an interesting story as a kind of biography than
You got
they would.
more material to start with.
Yeah.
When will your electron book be on the market, do you think?
It'll be, I think, sort of late summer, early autumn next year.
Love to talk to you again about that. This is really interesting talking to you. Is there anything we have missed that we should have asked you about multiverse in your book, which for everyone it's widely available. You can probably get it at your local Barnes and Noble maybe, but certainly off of Amazon and in Books A Million and such. Have we missed anything?
No, I think we've covered an awful lot. There are always little bits extra, but I think we've covered the main points here.
Can you tell a difference in the audiences for your science books in the country in which they're published in? Because you're publishing internationally, so does the UK have a different take on things than the United States or another country, or what have you noticed?
I don't think there's a different take. I mean, certainly when I've written for an American publisher, I might have had to phrase things a little bit differently because, we all know about some words that we use differently. But I remember in a physics book I wrote for an American publisher a while ago, I referred to something called skirting boards, and the editor had no idea what a skirting board is, which is basically a bit of wood sort of along the side of a wall towards the bottom, towards the floor. We call them skirting boards. I guess you call them something else. I don't know what. I've also referred to something called a coconut shy to demonstrate some physics principles, which is again an old English term for a kind of fairground thing where you throw balls at coconuts and you try to knock them off. A bit like throwing a ball at a can or whatever, but it's a coconut. It just didn't mean anything. So it's more a matter of making sure the language I think is international as much as possible.
Anyone have a final comment or question? Because I know we.
Yeah, I was wondering about coverage of dark energy, if you touch on that in the book. I obviously that's associated with our universe. I we don't know if it's affecting other universes, but I guess there's some data now from the DESI instrument that dark energy is not as strong as it was originally thought to be. And I'm just wondering if you touch on that at all.
Uh, Not really in this book. I have actually written another book on dark matter and dark energy, so do more in that. Although it predates obviously the recent discovery, but even back then there was a certain amount of doubt about the level, the strength, if you like, of dark energy. And again, it's a topic that um, needs more exploration. Here, at least, we do have something we can measure, something that we can look at. So it's not in the same class, I think it's fair to say, as multiverse. Dark matter and dark energy, we know something's happening. We just have lots of interesting theory as to why that's happening.
Yeah, I have a friend, Catholic friend, who thinks dark energy is the Holy Spirit.
Okay.
Maybe it is, John. Who knows? I have a final question for you. I co-host another show with a chap named John Batchelor, and he has a favorite question he likes to ask people that we've gotten on the show that have written a journal article, like in Science or Nature or something, and says, if you had an unlimited budget, what would you do with it, and would it expedite your research? So, on the assumption that there are scientists out there researching multiverse, and maybe my assumption is not wrong, is progress in trying to understand this, maybe confirm it as a theory rather than philosophy? If you had unlimited money, would that expedite coming to an outcome that might satisfy inquisitive people that don't want to keep waiting for answers that never appear? Is this a function of throw more money at it and we'll get the answers quicker?
I think it's fairly unlikely with multiverses, to be honest. I mean, there are other aspects of physics where that absolutely may be the case. We know that the standard model of particle physics has some small issues that may turn out to be really big issues, and we may need something different. So obviously, particle colliders, all that kind of thing, may well still be very useful to put money into. But the trouble with the multiverse concept is finding any mechanism to provide evidence. And I think it will remain, frankly, one that it's interesting to think about. We don't have to always be doing something that has an application that is necessarily going to have a straight answer. Otherwise, we wouldn't do things like philosophy. And I think this is the philosophical end of physics or cosmology.
So then what do you suggest for older guys and gals that want answers before we check out of this plane? How do we get answers to things that we've been interested in all our lives, and we really would like to have answers to them? If we can't expedite it with money, is there any way to expedite answers to some of these great questions, or are we just stuck in the chain of evolution, I guess?
I think as far as multiverses go, as I say, I don't think throwing money at it is going to make any difference. But I really would hate it if everybody said, okay, we're just not going to talk about it anymore because it's fun. And there wouldn't be any more Marvel movies and that kind of thing. So yeah, no, let's go with the multiverses.
Thank you very much, Brian, for being with us. I hope we can talk to you about more of your work later on another program. And we really appreciate your being with us this evening time in England. And have a great holiday season and a wonderful start to 2026. And thank you once again for being with us on the Space Show.
Oh, thanks very much for having me. Bye.
Everybody, we have open lines on Sunday, and don't forget we're in our fundraising period. So if you like us, support us. That seems rational. Thank you again. Everybody have a great weekend coming up. Goodbye from Brian and all of our what we like to call wisdom team and the Space Show.